chair of the Ecologically Sound Practices Partnership. And I'm also on the board of directors of Marine Conservation League. So this is a happy moment for me when both organizations are sponsoring a project, and that's because we have so much interest in the subject and the person together. So that's really good. I'll be saying more about ESP shortly, but I would like to just say that we have an agenda for you. You saw the agenda, sent it out. Did everybody get an agenda? And yeah, because sent it a few times, but really happy to see that that most of you got it. So that's very good. We're welcoming you now. And then my colleague, Ken Strong, you want to say a few words, Ken? Ken is with the Climate Action Working Group, and he's also with Marine Conservation League. So you can say a few words. And then the other person who's helping put this all together is Mark Brown from MWPA. And we'll hear from him in a few minutes. So you want to say a few words, or did you want to wait and say it when we do the introductions?
Let's just wait then.
Yeah. Okay. Right. Okay. Well, we can then begin unless anybody has some urgent subject they want to bring up. I think we will begin and welcome all of you. It's a really good group, and we're pleased to have you. We want to just a few housekeeping things. We want to make sure that the questions that you raise will be, you can put them in the chat. And if that doesn't work, or if you have something else, you can always raise your hand, and we will be able to call you. So, and it is this. You see, there's a message here. This is being recorded, so I just think you ought to know that. So let me begin by telling you that not only I'm with ESP, but I'm also actively works with a marine wildfire, and I'm on what is called the Advisory Technical Committee, and as a non-voting member, and but ESP is a collaborative. For those of you who don't know, we're a collaborative of five fire agencies and the environmental and climate community in Marin, and our purpose is to assist Marin wildfire in delivering its work in an environmentally sound way. And the goals are to prepare what we call a living, flexible set of recommended best practices to guide wildfire risk reduction and provide expertise during the development of projects, particularly relating to those that are for managing vegetation on the wildlands, homelets, landscapes, and other properties. So ESP recognized in the beginning the primary goal of MWPA is wildfire risk reduction. In June 2020, a mix of us began working on recommendations for three sets of foci. One, veg management and habitat protection, the other, carbon resource management, and the third is defensible space of ecological benefit. And so these goals are meant to meet threats causing the global economic crisis. So we're also addressing biodiversity loss, increased drought, flooding, and pollution. And we've been busy, and we have meetings like this every month or 6 weeks, and we try to keep everybody all in the different fields up to the best level of science and also of interest. And these days, there's so much interest, and we're just pleased with it that we have this interest. So I want to introduce Mark Brown, who's going to say a few words about about himself and maybe bring us up to date on MWPA, and also and he can talk for a minute about his working relationship with Daniel Swain. I also have had a very small time with him. And the last meeting we had was 2 years ago, I think. And he was here, and now he's in Colorado. We're going to introduce him soon. But before we do, I want to just bring Mark into it. Mark, are you there? I don't see you.
I'm here, Bill. Thank you very much for the intro. I'll say much less about me and more about our relationship with ESP, and also really happy to be able to partner with ESP and the Marin Conservation League to bring Daniel to speak with us again. And I thank Daniel for especially the again part, to keep coming back so we can listen to you more and more. It's greatly appreciated. A quick update on the Marin wildfire front, and then I'll share some of the conversations Daniel and I have had that I'm lucky enough to have been able to participate with Daniel on. And then I'll pass it off to Ann Krelock, our planning and program manager, to kind of talk about some of the on the ground work we're doing. But at a high level, Marin wildfire is entering into our work plan development season. That's always starts in around November. That's when Ann gets really, really busy working with each and every one of our member agencies to develop the work plan. Two items I wanted to talk about today was updating our community wildfire protection plan, which was last published in 2020. And at the time that we had published that CWPP, it was a state-of-the-art CWPP. But the wildfire space and the science and technology space has grown so fast that what was state-of-the-art 5 years ago is completely outdated now. When that CWPP was published, it was a snapshot in time. It was fuel data, it was resident population data, it was inspection data from 2019. And there was no mechanism to continually update that so we can have a current picture of what our risk assessments really look like in Marin. So as we started developing a lot of the tools that we were using within Marin wildfire to measure the risk reduction that we were creating through our work, it felt like we were creating a dynamic CWPP. So when it came time to renew our CWPP to be able to stay current, because you're supposed to redo it every 5 to 10 years, we decided to go with what we're calling a dynamic CWPP. So each year, we're going to be able to go right back into the CWPP, input the data of the work that we've been doing, input the data our residents have been doing, and automatically get new data pumped out of our CWPP. And we've decided to really focus in on the evacuation zone level. So those of you that are participating in your Firewise communities, you probably are well aware of what your evacuation zones are. If you don't know what your evacuation zone is, I encourage you to go to emergency.marincounty.org, or excuse me, .gov. Click on the evacuation tab, and you'll be able to find out where your evacuation zone. But within the Community Wildfire Protection Plan, or the CWPP, we are able to prioritize down to the evacuation zone level. And we'll be able to say, in this zone, this type of work is going to be really important. In this zone, maybe alerts and warnings are going to be more important than some of the vegetation management work. So we're going to be able to slice and dice down to the evacuation zone level. We're really excited about that. We'll be giving an update to our operations committee Thursday, and then we'll be giving an update to our board of directors on the following Thursday. So very excited with the CWPP. We are going to be doing community meetings starting in February. We're going to have one community meeting in each of the Marin wildfire zones, and also in Tiburon and Belvedere. Spanish translation will be available at every single one of them. And rather than death by PowerPoint, these meetings are going to be more of a mini fair, where we'll have stations within the meeting space, and the residents will be able to go to the table with the information that they are really interested in concentrating on. And I'm looking at Jen Gauna now, and want to thank Fire Safe Marin for securing a grant and supporting and leading us through the community meetings when we start and embarking upon those. So thank you very much for that continued partnership with Fire Safe Marin. And then I'll move on to a new initiative that we have going in partnership with the Marin Community Foundation. we received a 2-year grant for staffing for 2 positions at Marin Wildfire to create what we are calling Zone Zero in a Box. And that is for residents who want to become compliant in Zone Zero for one of 3 reasons, if not all 3 reasons. Number one, we know that Zone Zero is one of the number one ways coming to compliance with Zone Zero, and that's the first 5 feet from the house, but it also includes home hardening for the house. The Zone Zero is the first 5 feet, and if we can have nothing be flammable within that 5 feet, then the chances of a home surviving through an urban conflagration or even keeping an urban conflagration from starting dramatically increases. So we're going to have residents that are going to want to become compliant for Zone Zero because they want to decrease the chances of their homes being destroyed in a wildfire. Number two, if you've been tracking the Board of Forestry and the work in Zone Zero and the definition of Zone Zero, our local municipalities are going to need to adopt ordinances for Zone Zero. So residents are going to want to become compliant with their ordinances. But I think the biggest kicker is going to be the insurance industry. I'm a firm believer that the insurance industry is going to start saying, if you're not Zone Zero compliant, we aren't going to insure you. So I think that's going to be one of the keys in the future. So Zone Zero in a Box is designed for our residents who want to become Zone Zero compliant. They can pick up the phone or get on in through our Fire Aside app and learn how they can be Zone Zero compliant. And we're calling it the easy button. We'll walk the residents through becoming Zone Zero compliant. And then for communities that are well organized, like the 86 Firewise communities that we have in Marin,
Yeah.
if people start coming together as a Firewise community, we'll be looking at group discounts and be able to drive that cost down by the contractor being coming into a smaller geographical area. And that's a win-win to me. We can get the costs to go down, and we know that we get more resilient with more houses that become compliant. One house in the neighborhood, it's nice, but when you get a high percentage of houses in the neighborhood, that's when we start becoming compliant and resilient. And with that, I do want to mention how great it is to be able to have Daniel here. Daniel, again, thank you very much for participating. What I love about Daniel is he takes the very complex science of climatology and makes it understandable for people who aren't scientists. That's not always an easy thing to do. And when I hear Daniel speak, I could see these mechanisms he's talking about, and it actually starts making sense to me. And then through my firefighting career, the changes he describes in the weather science, I could start seeing how the stuff that I was seeing change on the fire ground in direct correlation to the weather changes that he's been talking about. So being able to contrast and compare my observations on the fire ground to Daniel's scientific observations and have them reinforce each other has been super exciting for me. I remember sitting in my car for a half an hour, and unfortunately, that was all the time that we both had. It was one of the most fascinating conversations I ever had. So I look forward to hearing more from Daniel. Yeah, and with that, I think I'll pass it off for Anne to talk about some of our projects that we've got going.
Yeah, and I see you're here. I'm so pleased. Yeah.
Yeah,
So
I'll just provide a quick update. As you know, we all take a house out approach with Marin Wildfire. So I'm going to start at the house and then go out towards shaded field breaks with a few updates for the year. So inspections are a very key component of the work that we do. And this year we've hit about 35,000 home inspections. So looking at home hardening and defensible space and how to make those homes more resilient to wildfire. So big stuff happening there. We're also, using our grant dollars to reward residents and reimburse residents who are doing things to make their homes more ember resistant, particularly a small suite of activities such as vents, gutter guards, that first 5 feet, that connection between fences and homes. We've awarded or approved about 321 grants so far, and that's up to $1,500 per grant, and we have about $800,000 to give away this year. So we're well on our way to doing that. our chipper program helps homeowners and residents who are doing their own defensible space. We've got over 5,090 homes serviced this year, and that is an increase over last year, and a lot of new customers as well. So that's really great. We've also moving out to roads. We're doing a lot of work along roadways and a lot of work with our member agencies to help track that work along roadways. So we've been able to create through with our GIS contractor a really easy way to show which roads have been treated. So stay tuned. We'll have our online maps really showing roadside vegetation management soon. We've also been treating a lot of vegetation along, that kind of edge of the home, the built environment, and the wildlands in our shaded field breaks. We've treated about 2,000 acres or so far. Those vegetation management projects are really most of them are wrapping up for this season and ahead of the rainy season. We've got a geologist who always advises on all of our projects. So you may see folks putting out, material to make sure there's no erosion or something like that before the rainy season really gets going. And you may see some crews still working into the winter and hand pulling broom, because when that soil gets nice and soft, you can pull that broom out and get the roots as well. So you may still see some activity out there. So let's see. Speaking of, we got a question about the GIS. We use a nonprofit, Green Info Network. They're fantastic, and they've done a lot of work with a lot of different great agencies. Green Info Network is our GIS contractor. So those shaded field breaks, we really love to bring people out to our projects. So I want to put a plug in for some future field trips that we have in the works. We held a field trip in October, and Bell and ESP helped co-host that field trip, and that was to the Greater Mill Valley Field Break. That's a 23-mile long, narrow, linear shaded field break that basically encircles Mill Valley. And so that was kind of a before snapshot. We'll bring people back out to that project area as like an after snapshot sometime in the spring. So keep an eye out for that field trip. In January, we're going to bring folks out to the Sea Haven area of Inverness, where we're able to do work on the northern extent of Inverness, right on the state parks boundary. We'll be reaching out to residents in that area first. Probably require RSVPs. Parking is limited. We don't want to flood the neighborhood with people, so we'll be reaching out to Inverness folks first, and then reaching out to the general public for that one. But that one's coming up in January. We're also looking at a demonstration garden in Novato to bring folks out to, and San Rafael Hill, where vegetation management has been doing really great stuff. Gorse, broom, a lot of non-native weedy species, and a lot of ignitions from the unhoused population in that area. So really key project there that will probably include some good fire, some prescribed fire in the future. So keep an eye out for that invitation also. So a lot going on. And then in addition, we're planning for the next fiscal year. So right now we're just jumping into the work plan development season, so we can get an eye for what fiscal year 26-27 is going to look like, as Mark mentioned. So with that, I'll stop so we can hear more from our speaker today. And feel free to reach out with any questions, or I can post some links in the chat and answer questions in the chat as well. I've got a map of vegetation management activities that are Measure C funded that I can throw the link in the chat so you guys can take a look around. And I'll put a couple of other links in there as well.
Yeah. Carolyn, do you have your hand up? Did I see you with your hand up?
I don't think so, Bill.
Oh, I see your hand, but it's not, I don't know what it is. Anyway, that's okay.
You know what? It's the sun coming in my window.
Okay, that's good. Always good to
See
have the
that
sun.
white thing? Anyway, I'm not raising my hand. I'll try to fix that.
Okay. So, Anne, we don't have time right now, but at some point, and I'd like you to tell people about the experiment we're doing with the Advisory Technical Committee and making it into kind of a working group and the subjects we're working on and how they relate to the operations and future planning and risk taking. It's really interesting. So I don't have time, we don't have time right now, but let's do that at some other time. Okay, good. Okay, so let's see. We're ready now to begin the presentation. And first of all, we have Daniel Swain with us. And
Bill, can I say a few words about MCL before we actually get into
I'm
Daniel?
so sorry. Yeah, Ken,
Yeah,
I
no
forgot.
problem.
Go ahead.
Yeah. So for those who are not familiar, first of all, I'm Ken Strong. I'm director of Marine Conservation League and co-chair of our Climate Action Working Group. And we thought it was great that Bell had scheduled this wonderful meeting with Daniel Swain, and our Climate Action Working Group does not meet in December, so we thought it was wonderful to be able to piggyback on this. For those who don't know Marine Conservation League, we've been around for 90 years. Our mission is to preserve, protect, and enhance the natural beauty of Marin in a changing environment. We have 3 active committees. We have a Parks and Open Space Committee, and they actually have a meeting coming up this Thursday, the 11th from 3 to 5, about conservation values of Marin's working lands, and which Nancy Scolari, who's the Executive Director of Marin Resource Conservation District, will be one presenter. Lily Verdun, who's the Executive Director of MALT, will also present, and D.V. Rao, who works with UC Extension on livestock and other advisory matters. We have a Land Use and Transportation Committee. Most recently, what they were doing last night, they were testifying at the Novato Planning Commission after having prepared a letter critiquing the draft environmental impacts report or statement for the Costco gas station that's proposed there, particularly pointing out that the draft report did not take into account the potential for new people traveling that are not currently Costco customers traveling to the Costco if they put those gas stations in, and how that additional traffic will impact both traffic and vehicle miles traveled calculations, which will affect whether or not there are no non-mitigated harms. I didn't say that exactly right. I'm probably going to get corrected by somebody. Our Climate Action Working Group, a couple of things we've been working on lately. We've been very actively following and engaging with Marin Clean Energy, MCE, for a number of years. We were very involved in the in public comment and letters arguing for their need to create a permanent finance committee, which they have now done, thanks to some help from the IJ with some very good articles there. We've also we've been commenting to what is now the Bay Area Air District on their upcoming regulations, which, because of air pollution emissions, our indoor air or pollution, NOx emissions from our water heaters and our space heaters produce more NOx air pollution than either refineries in the Bay Area or passenger car travel. So it's a big source. And in order to address the health impacts of that, the Bay Area Air District has issued rules that starting January 1st, 2027, whenever after that you have to replace your water heater, you're going to have to do it with a heat pump. Don't have to do anything until it burns out, but when it does, that's what the rule provides for. And so we're actively advocating for that, both with our county supervisor, who is on the committee, and also with the committee more generally through letters that we've signed on to. A couple of housekeeping things before Bill starts introducing Daniel. Everybody should be sure and mute themselves. Daniel's requested that we sort of save questions for the end. If you put your questions in chat, we'll try and ask them out of chat if we've got time. Then it's possible we may call on you. But given the number of people, we've now got 72 participants here. I think probably not asking questions verbally, but just collating them through the chat is probably going to be the best way to go. So with that, Belle, I'll turn it back over to you, and you can introduce Daniel.
Okay, thanks, Ken. That was good. Well, so Daniel, your recent you're with UC right now, right? ANC.
Yes, University of California Agriculture
Yeah.
and Natural Resources, so
Right.
UC A&R.
So maybe I'll let you explain your situation. It's a little complicated, but it's really interesting and important. And so he's going to focus today in his presentation on hydrocarbon whiplash in California, and I think he may be one of a key researcher on this subject. And also we're going to, if possible, we'd like him to talk about what's happening with decarbonization, meeting our decarbonization goals at different levels. And it's complicated, and it's definitely complicated at the federal level, but maybe you have some way of helping us understand what's happening at the more micro level. And also, but most important is we're learning about what's involved in communicating about science and climate change in a broader context to the broader public. And he has agreed to answer questions and discuss with Mark Brown any challenges that he sees and any of us see in Marin County. I just started out by saying that he's a climate scientist. He's focused on the dynamics and impacts of extreme events, including droughts, floods, storms, wildfires on a warming planet. And I'll leave him to talk about his scientific work, but we want to concentrate. We're very pleased and interested is that he works extensively with journalists and media partners, serving as a climate and weather science liaison in print, television, radio, and web-based outlets to facilitate accessible and accurate coverage and conversation surrounding climate change. And he also authored the widely read Weather West blog, and it can be found on Twitter, Blue Sky, YouTube, publications. And I just wanted to mention something that we're very proud about, and he must be too. He was elected to what is called Time 100 Next, and it's a category that a recognition. It's an honor to be, and he talks about this he's on the 2025 Time magazine. It's the 100 next 100 next list for 2025. And we wanted to take a moment to let him reflect as he did in writing, in person, on what this recognition means to him personally, and also on the broader importance of supporting those who are doing their very best to provide constructive context surrounding global events from the weather on. And it's in a moment, and I like your term, surging misinformation and widening societal divides. And so let me just present our friend and mentor and a person we look up to, and see he's taking on the challenges that all of us think have to be taken. Thank you, Daniel.
Well, thank you for that introduction, and thank you for all of the kind words. It's been fun to be able to sort of be a little bit of a recurring visitor in person and virtually for several of the entities and groups that are participating in this event today. And actually, one thing I've been doing, just as you were speaking, is there were a handful of images that I'm actually just pulling off the web that I just wanted to throw in to the slides I do have prepared for today, just at the very end of this, so that I can talk a little bit more about the decarbonization piece. I didn't have too much on that, but I have several nice little succinct slides that I should be able to pull up now. And I'll do that at the end of the talk, actually. So this will be sort of a bonus round, if you will. And I am literally finishing that slide as I'm speaking to you right now. So hopefully those clicks haven't been too distracting. Okay, so that is now done. Let me go ahead and share my screen so that you can see what I'm seeing. You'll see um, a mirror image of my screen for a moment, and then you should then see shortly thereafter, right around, well, that's actually the end of my slides. Let me quickly go back to the beginning. You should now see, now, full screen,
Ah, there you are.
nothing cut off at the bottom. Just let me know if for some reason it looks like it's kind of cut off.
Looks good.
Yep. All right, the very bottom should say December 2025. All right. So, as mentioned today, I'm going to talk a little bit about uh, the observations and the future surrounding California climate, and in particular, California hydroclimate, and how increasing variability, these increasingly wide swings between very wet and very dry conditions, is really a driver of a lot of what we've been seeing all around us recently, and also probably going to be a signature of even larger changes moving forward. And I should just take a moment to mention that again, I my role is primarily with the University of California Agriculture and Natural Resources, or UCANR. I also have a role with the NSF National Center for Atmospheric Research in Boulder, Colorado, but my main role is now with UCANR, and that's a role that allows me to have a lot more conversations like the one we're having today.
Good. Yeah.
So I thought I'd do a real quick overview on global warming writ large. This is a map that I have updated now every year for the past probably 15 years. This has been something that's been out there for a long time, and it just keeps getting more and more red with each passing year. So the Earth, of course, is warming, but I think the thing that is maybe still not as obvious as I wish it was in certain circles is that warming itself is only really an indicator of a broader problem, which is changes in global climate that extend well beyond mean temperature and even well beyond temperature as a physical variable in the first place. The warming we're seeing today is essentially 100% caused by the increasing accumulation of heat-trapping greenhouse gases in the Earth's atmosphere due to human activities, which primarily means fossil fuel burning, but also things like land use change, deforestation, agriculture, things like that. So a bunch of things that we do that cause net release of these heat-trapping gases into the atmosphere, which warms the planet. And again, these are gases that are what are known as evenly mixed. So you emit them from one point on Earth, they spread all around the world and ultimately result in warming everywhere. So this is not a case where you emit more pollutants locally and it gets warmer locally. This is sort of a problem where we're quite literally all in it together. It's the same atmosphere and we share that air. Human activities, as I mentioned, are the essentially the sole cause of that warming, although there are multiple subsets of activities that contribute to it. And at this point, we've now seen several individual years that were around 1.5 degrees Celsius warmer than the long-term average. The multi-year baseline warming is still around 1.3, 1.4 degrees. So that's between 2.5 and 3 degrees Fahrenheit, which might not sound like a lot, but it actually, in context, is a very large number because we are not done yet. And where we are today is essentially at a point, I hope an inflection point. And you can kind of see that this is an update as of last month as to how our global emissions have continued to change over the last 30 years, or I guess that's close to 40, 35 years, I guess, at this point, is that black line there. And the main point I wanted to emphasize here is that they have continued to steadily increase. So this is not just that the concentration of greenhouse gases is still increasing rapidly, which it is, but this is to say that the year-on-year increase but in the increment by which that number is increasing is itself still increasing over time. And you can see that little blip there around 2020. That was the peak pandemic effect. And it was very, very small in the scheme of things. It's certainly noticeable there. It's really the only period where we've seen a significant blip on the radar, but it's not clear yet if we've even peaked our global emissions. And so the really the main point here is that there's a lot of warming left to come. So we're still waiting to bend that carbon curve, and in this sort of this forward-looking projection, all of these blue and green curves, that's certainly what we still expect to happen eventually. But the eventually being a really important operative word there. We don't know exactly when that's going to happen still, and if it doesn't happen soon, that's going to have major consequences for the total amount of warming that we actually experience. So we hear about the progress in the electrical sector, we hear about the ongoing decarbonization of transportation, electricity generation, green energy. All of that has indeed experienced rapid progress, but the net effect of it is that the other sectors are still emitting so much carbon that they continue to outpace that progress in terms of the global net emissions. So the real question is, when does that curve bend? And it hasn't yet. In fact, 2024 emissions were the highest on record, and it looks like 2025 will again see a new record peak in carbon emissions. So we are currently on a path to probably double or more the warming we've seen so far, but with a pretty wide uncertainty bars because there's a lot baked into that assumption about geopolitics over the next few decades, which I wouldn't even presume to pretend to predict. There's a lot baked into that based on our assumptions about the what's known as the climate or Earth system sensitivity, essentially meaning how much warming you get from a given increment of carbon emissions. And so we have to try and predict both how much carbon we'll emit, which is essentially a political and societal question. That's above my pay grade anyway. And we also have to then predict at a particular amount of carbon emission in the future, how much warming will it actually generate? And there is both of those numbers still have considerable uncertainty, hence the range is wide. But the historical empirical data are telling uh, a pretty stark story about where we are, where we've come from, and the fact that we haven't yet begun to change that trajectory, even as progress, real progress, does emerge in some sectors. It hasn't really yet emerged in other critical ones. And so I think the reason I mention this is not to depress everybody, but is really just to illustrate, to be honest about where we are, and then also to emphasize that we've got a lot more warming coming. For most of us, it's going to continue to get warmer and warmer the rest of our lives. And I say that as a relatively young person, myself included, even if we really do bend that carbon curve soon, there's going to be a lot more warming to deal with. And so one corollary, one consequence of that reality is that we do have to also be adapting to climate change. We can't only try to solve the underlying problem of the warming itself. Of course, we have to do that too. We have to walk and chew gum at the same time, but we can't ignore the adaptation side of things because if we do that, we're going to see a lot of harm occur in the meantime while we're working on fixing the underlying problem because we aren't trying to shore up our defenses against the things that we know are changing in the meantime. And all right, so let's back up a little bit and just have a bit of a primer on California climate. And I've been showing variations on this slide now for the better part of a decade, or actually longer at this point. But the reason why it's kind of perennial is that over the course of that decade, people have been interested in it either because we've been in a historically severe drought, or we've had some really heavy rainfall, or we've had terrible wildfires, or some other sequence, some other subset of that. So we've sort of experienced a wide range of extremes. And part of the reason for that, geophysically speaking, is because California does exist at a kind of climatological geographic transition zone. It also helps that California is a latitudinally extensive state. It has a large north to south expanse, essentially. But the reason why it's positioned at this climatological margin is so important is it means we're essentially at the periphery of the Pacific Storm Track. And this Pacific Storm Track is not a static feature. It wiggles around over time. It's farther north in summer. It's why the summer in California tends to be dry. It's farther south in winter. It's why, at least in most winters, it rains fairly regularly in winter in California. And in the spring and fall, it can kind of wiggle around and be in either place. It also explains why we get really dry years and really wet years, because that storm track in some winters is much farther south than it is in others. This is one of the main reasons we talk about things like El Nino and La Nina, because they modulate the latitude of that Pacific storm track. But the net effect of this is that we have both a strong seasonal cycle in precipitation, those wet winters, dry summers, and the transition seasons that can kind of go either way, and also a really strong latitudinal gradient in California climate. You know, the North Coast is extremely wet. You see rainforests up there. In Southern California, much of it is semi-arid to desert. And the reason for that is that California kind of is bisected by this typical location of the storm track. To the north of it, it's wetter. To the south of it, it's drier. And that has the other effect of allowing for very high year-to-year variability of precipitation and also of flood and drought risk, because we really only have one season, if you will, to meaningfully accumulate a lot of precipitation in California, and that's generally winter. We know that if we have a dry winter, we're not going to get enough rain in summer to make up for it. That has actually never in recorded history even come close to happening in California, and for this reason, for the reasons we understand. It's sort of an intrinsic part of California climate. I only raise that because it's not true elsewhere. In most of the rest of North America, and really in most of the rest of the world, there are at least two distinct rainy seasons, if not a year-round rainy season. And so you have multiple opportunities in any given year in most places to make up a given precipitation deficit. But in California, if you have a dry winter, you're pretty much out of luck until at least the next winter when you might make that up. So it's easier to enter drought, but likewise, it's also easier to enter a flood regime because it only takes a few really wet weeks to bring about those big floods in winter, because we sure can get a lot of water all at once. And it's worth noting that this fall in Southern California, it was in parts of the Central Coast and the Southern Sierra, was literally the wettest fall in over 100 years of record keeping, which immediately followed last year the driest autumn and start to winter in over 100 years of record keeping. Keep that in mind as I talk a little bit more about it. In California, and I pulled up this plot just yesterday for Marin County specifically, updated through this year. So this is fresh off the presses to the end of October. Obviously, it's getting warmer in California, including in the Bay Area. You can note that 2025, this past year, was not necessarily among the top 3 or 4 hottest on record. If you look at the rightmost orange dot on this time series plot, but you'll also notice that in any year prior to about 1995, this would have been the warmest year on record in Marin County, even though in the context of the last decade, it was only the 5th or 6th warmest year. It felt kind of mild this summer in a lot of coastal California and the Bay Area, and this is kind of reflected here. But nonetheless, the long-term warming trend is clear, and even what a lot of folks perceived as a pretty cool year in parts of coastal California in 2025 was, in fact, one of the hottest years that California would have ever seen prior to the mid-90s. I think that's a good benchmark for just how different things already are. We do see actually faster warming away from the California coast, so in that sense, Marin is a bit of a conservative indicator of climate change in California. We also see more warming at higher elevations and inland generally. So Sacramento, for example, warming faster than the Bay Area, and some of the hilltops warming faster than the valleys. And we have seen that big stair step upward. Notice that almost every year, except for one in the last decade, has been essentially warmer than almost all years in the 20th century that we saw. And this is true both specifically in Marin for the audience on the in the call today, but also generally almost everywhere else in California as well. And if we do look at California overall, which is what this plot is now showing, we see that in summer in particular, it's gotten a lot hotter. In fact, we've seen much more rapid summer heat wave warming than the rest of the time. And believe it or not, 2024, despite being another summer that was not that hot along the coast, it was actually California's hottest summer on record across inland areas. So that real contrast between coastal areas and inland areas, just because it's been cool and foggy, if you live along the coast, does not mean that similar conditions are occurring inland. The result of this is that all of California's hottest summers on record have now occurred in the past decade. Certainly something that you would not expect to see if the climate were relatively constant over time. But there's been a bit of a reprieve along the coast, as I mentioned, and you can kind of see that if you look at California summer warming, excuse me, up top here with that really strong warming trend since the 1970s here. That's the top plot. But if you look at a place like San Francisco County, for example, well, it's still getting warmer in summer, but it's getting warmer 4 times more slowly than it is in California overall. So what we're seeing is that the warming is a lot faster in places that aren't affected by the marine layer. And Marin County is, on average, a place that is affected by the marine layer. And so it was warming a bit more slowly. Not quite as slowly as San Francisco, but it's somewhere in between. That's partly because coastal fog is still making a pretty strong showing in most years. Notably, the fog that the Bay Area and the Central Valley is having right now, by the way, occurs for entirely different reasons than summer fog. Right now, it's that cold and clammy Tule fog, which did indeed used to be more common back when temperatures were cooler and when air masses weren't as warm as they are today. But this present episode is a bit of a harkening back to older, cooler times. Probably not in a bad way in a lot of respects. That Tule fog is helpful in a lot of ecosystems, and it's also helpful for agriculture, although I know a lot of folks are starting to get tired of it after 2 or 3 weeks of cold and damp weather. Um, the future of coastal fog, here I'm talking about the summer marine layer type stuff, is still surprisingly pretty uncertain. We don't actually know what's going to happen with summer fog in California, and the reason for that is there's two distinctly competing effects. One is that we have the influence of overall drying of air masses, which, as you would expect, would attenuate the occurrence of fog. But on the other hand, the fact that the inland areas are warming really fast and the coastal areas are warming only slowly tends to result in a pressure differential that kind of draws that cool, moist marine air inland more strongly than used to be the case. So the air is drier, but that vacuum pump, if you will, is operating at greater strength, that natural air conditioner. And so that's kind of the tension that we see. Which process will win that tug of war? We don't know yet. We honestly don't know yet. So marine layer trends remain, pun intended, still a bit foggy. But when it comes to hydroclimate, which is really the focus of the talk today, how have things changed recently? Well, we can look at average precipitation, and it essentially hasn't changed in the past 126 years. That's a pretty robust indicator of no change in average precipitation. But if you look at the moisture variability, what is the magnitude and frequency of the swings between really wet and really dry conditions in California? Those have increased noticeably, especially in the last few years. And we also see a strong and sustained trend towards longer and more severe droughts. So how can these three things all be true in the same place at the same time? Again, much more frequent and severe drought, and yet essentially no change in average precipitation. Well, I'll get to that in a minute. But first, I want to introduce this concept of precipitation whiplash, which is this notion of wild swings between wet and dry and then back again. And there's a few motivating pieces here. This was one from Southern California, one of my earliest examples from slides that I started creating in 2018. This was a particularly dramatic example where we had the Thomas Fire in December, which became the largest fire in modern state history at the time. That's since been supplanted, I think, 4 or 5 times since 2017. But then that was immediately followed by a very extreme localized downpour that led to one of the worst mudslide and debris flow events on record. It killed a lot of people and destroyed a lot of structures in Santa Barbara County. That was mainly in Montecito. But if you characterize the climate during this period, as various climate summaries did, on average, between December 2017 and January 2018, it was mostly sunny and breezy with below average precipitation, which I think most folks would agree does not reasonably characterize the catastrophe that unfolded in this region during that same period. So, my point here is that if we only consider changes in the average climate, then we're often going to miss the point entirely in some cases. And there's other examples from Northern California. I've been adding new panels to this slide now every year or so for the past 12 or 13 years, and it just keeps going back and forth between extreme aridity, extreme water, extreme wildfire, and then back again over and over and over again. A little bit closer to home in the North Bay. Again, we've seen this alternation. I can illustrate it with photos. I can illustrate it with data. I can keep updating it year on year on year, and we just get more and more. We can call it anecdata, I guess, because they're anecdotes that are in support of the actual underlying quantitative evidence. But a lot of it comes back to something that looks maybe a little bit scary mathematically, but I'll break it down for you, and it's known as the Clausius-Clapeyron relation. Essentially, this is a well understood rule or equation in thermodynamics that essentially tells us that what is known as the saturation vapor pressure of air increases exponentially with temperature. And here, exponentially means just that. I'm speaking in a quite a literal mathematical context, not figuratively. What this means is that as temperatures rise with global warming, that brings about a nonlinear increase in the amount of water vapor that air is capable of holding. The maybe the simplest version of this is that warmer air equals thirstier air, and this is actually derived from science that goes back, that originates in the mid 1800s, long before we had computational models or these large Earth scale simulations of climate change. This is something that was actually predicted to characterize the variability of hydroclimate long before we even had a coherent global theory for climate change. So it's remarkable that this ends up being a really important concept, even in this moment where we have all these advanced models, we have all these satellites, we have all this data from observations, we have data from models that this one fundamental equation, and it literally is just that long, describes a lot of what's important today. So that's the undergraduate classroom or graduate classroom level version of it. But wow, if you break that down to sort of the nuts and bolts of why that's important, my colleagues and I have termed, and this is finally published as of this year, an analogy for this, which is the expanding atmospheric sponge effect. And essentially, it works like this: you can imagine that the pre-industrial atmosphere, essentially meaning the cooler atmosphere prior to the emission and accumulation of greenhouse gases in the atmosphere, kind of acted like an ordinary kitchen sponge of some ordinary size. And imagine now that as the atmosphere warms, that kitchen sponge, figuratively, is growing larger. In fact, we can quantify it with 3 degrees Celsius of warming. That sponge is going to be about 22.5% larger. So that's actually a considerable increase in the size of the figurative sponge. As temperatures rise and that ambient air becomes spongier, what that means in practice is that the ceiling on how intense precipitation can become rises, but also the ceiling on how intense evaporation can become. So imagine that kitchen sponge, that ordinary kitchen sponge, it has some ability to soak up water that you might spill, say, on your kitchen counter. And it has that capacity to soak up water even if you haven't actually spilled any water. So a completely dry sponge and then a comically oversized version of that same completely dry sponge, they have different potential ability to absorb water, even if there's no water available to absorb. So they might both have, at any given moment in time, no water in them. But if the larger sponge is completely saturated, it's going to hold, in absolute terms, a greater volume of water. That's essentially how the atmosphere is behaving in a warming world. And so, therefore, when the atmosphere is saturated, it has a greater capacity to be figuratively wrung out and to produce extremely heavy precipitation on the one hand. But if it's not saturated, if it's a dry sponge, which in California describes the atmosphere more often than not, when it's not raining or not cloudy, it actually has an increased potential to absorb water, to demand that water, to evaporate water from land surface, from plants, from bodies of water. So the net effect then is much heavier downpours, but also greater thirst and greater drought by the same atmospheric token, the same physical process. And this is what drives what we call increasing hydroclimate whiplash. The very same climate models in California that project relatively modest changes in the overall average precipitation in this part of the world with warming suggest that the very wettest wets and the driest dries will indeed become a lot more pronounced. That is striking given what we've seen recently, especially seasonally. And this is true also, where we expect that our shoulder seasons, like our autumns and our springs, on average may become somewhat drier, but the already wet season, which in California, of course, is winter, might become a bit wetter. So not only do we see greater year-to-year swings potentially on the horizon, but also the greater accentuation, greater swings from the wet to the dry season, even in a typical year. And that has some significant implications for the length of the growing season for plants, and therefore the length of wildfire season and agricultural growing seasons. I'm going to skip through this one. On the wet side of things, we know that the main moisture delivery mechanism, for better or for worse in California, are atmospheric river storms. So these highly concentrated plumes of water vapor that of air moving, being pushed by strong wind in the air above your head, and these are sort of your classic. Usually, your big winter storms in Marin County, the North Bay, these will typically be atmospheric rivers in some form. They're getting a particularly extreme one in the Pacific Northwest, by the way, right now, where record flooding is potentially going to occur on some rivers in western Washington state in the next couple of days. Northern California, of course, is, although foggy, otherwise quite dry and benign weather at the moment. But this is sort of California's primary moisture delivery mechanism. Without them, we'd see terrible drought. We'd have a very different ecosystem. So we do need them in some form, but also if we have a significant flood, you can almost guarantee that this is the cause. These moisture delivery mechanisms, these atmospheric rivers, we may or may not see more of them in the future, but the ones that do occur are very likely to be more intense than their historical counterparts, to the extent that we will eventually see the emergence of historically unprecedented atmospheric rivers of extreme strength that we didn't see before. And indeed, the Pacific Northwest may literally be seeing an event on that order right now as we speak. So California has a long history of flood risk, and I won't belabor the point too much here, but we sort of have underestimated our flood risk based on essentially getting lucky in the 20th century. We sort of, by happenstance, didn't see worse floods, but we certainly could have, and that's not really a comment about climate change so much as it is a comment simply about luck of the draw. We got kind of lucky in that respect. Not in some other ways, but we did with respect to flood. We can't expect that luck to continue moving forward. That would be in other words known as gambling. But we also have a change in the odds. We know that warming, that expanding atmospheric sponge, is upping the ante, if you will, on what's possible. So we're gambling with higher stakes than we used to with respect to flood and other things. And our own research suggests that the risk of an extremely severe statewide flood event in California has quietly doubled already in the background as of circa 2020, even as we've been more preoccupied with drought and wildfire concerns in recent years. So it's certainly not to negate the very real risk from wildfire, and I'll come back to that in a minute, but it's also just to emphasize it's probably not the only thing that we should be thinking about. And one of the keys in successful disaster risk mitigation and resilience is anticipating future bad things before they actually become bad so that you can mitigate them preemptively rather than reactively. And I'll skip this one because there's not too much snowpack in Marin County in particular, but just to point out that there are some parts of California, particularly the Central Valley and especially the San Joaquin portion, of the Central Valley, where future flood risk is going to be essentially in a different universe than it has been for most of the modern era of California water and flood management. So essentially seeing floods that are potentially 2 to 4 times larger, not 2 to 4 times more frequent, but literally 2 to 4 times larger in magnitude in this part of the state. It's unlikely that Marin County will see that large of an increase in the magnitude of floods, but we will certainly see similar increases in the peak runoff events during big winter storms. Okay, but coming back to drought and how some of these seemingly contradictory time series actually come from the same real world in a coherent sense, we again see a similar plot for the southwestern United States in general, with little or no trend in average precipitation, but a very strong warming trend over the past century, as well as a huge increase in the severity and frequency of drought. Uh, Really, this comes down to the fact that the same amount of rain snow just doesn't go as far as it used to. We see more precipitation now on fewer days, with more intense but fewer storms. There's less snowpack overall, but as I mentioned, that expanding atmospheric sponge is demanding more water from the landscape. One way to think about this is that all droughts could have been hot or cold droughts. It could have been unusually warm or unusually cool during a period of low precipitation, but now it's just warm all the time relative to history. And I think you can essentially blame the dry side of the atmosphere, the expanding atmospheric sponge, for much of this. Um, and one reason why this matters, I think that is prominent in the minds of the folks joining today, is that it really does profoundly affect wildfire burning conditions. As temperatures rise, that expanding atmospheric sponge is, as I mentioned, demanding more water not just from the passive landscape like soil, but also from plants themselves. And of course, vegetation is what burns in a wildfire by definition. What we see is that drier vegetation over a longer fire season means that the fires that do occur are both more intense, faster moving, and have more, I guess for lack of a better term, exotic behavior, more dangerous wildfire behavior than under more mild conditions. So it's not necessarily affecting the number of fires. In fact, we're actually in general seeing significantly fewer wildfires than we did during the 20th century, but those that do occur are preferentially becoming large and problematic. And one of the key reasons for this is that climate change has already doubled in autumn the number of extreme fire weather days just since the 1980s. So essentially, in my lifetime, climate change has resulted in about a doubling of the number of extreme fire weather events in California, and I'd remind folks that I'm relatively young. Uh, and so the dry side, the expanding atmospheric sponge, it really is the number one reason. It's the number one linkage between climate change and wildfire. And that's not just true in California, but in fact, people have drawn similar exponential curves in terms of wildfire risk throughout the American West and in the world. Vegetation dryness, which is almost one-to-one linked with atmospheric dryness, is exponentially, again, in a literal mathematical sense, related to wildfire extent and severity. And there are many regions in the world that have now experienced profound shifts in that level of vegetation dryness. There's another interesting addendum to this that has kind of arisen in the wake of the catastrophic fires in Southern California this past January, which is that we often think in the wildfire world that drier equals more flammable, which is a fairly obvious, intuitive thing to say. And of course, it is true maybe in a majority of ecosystems most of the time. Think of a forest, for example. Essentially, all else equal, the drier it is, the more flammable it is. Obviously, there's caveats to that. It depends on the species. It depends on the level of the understory. It depends on whether you got a deep duff layer or something on the ground. But all else equal, the drier it is, the more liable it is to burn, and the hotter it's going to burn if it does experience a fire. But there are other ecosystems where that's not necessarily how it works, at least on balance. And that's true in ecosystems where there's large variation from year to year in the abundance of vegetation. So think, for example, a grassland where in a really dry year, you just don't get a lot of grass that grows. But in following really wet conditions, you have abundant growth of grass and certain kinds of highly responsive scrub and brush. So in brushy, grassy ecosystems, you can actually experience an increase in fire activity following wet periods if it dries out sufficiently, because you actually have a lot more potential fuel for the fires to come. In that case, literally more fuel. And so that means, and what are these, what essentially are called fuel limited fire regimes, which are common in coastal Southern California, including in the areas that burned in January, you often have active fire years that follow heavy rainfall periods, which is in fact what did we experience between 2022 and 2024 in Southern California was near record wet conditions. But the key here is that there's another piece. There's a global warming twist, which is now increasingly these very wet periods are immediately followed by exceptionally hot and dry periods, leading to these episodic fuel accumulation then desiccation cycles. And we clearly see, based on research that was published earlier this year, that this is directly linked with wildfire intensity in places like coastal Southern California, but probably also in grassland environments and chaparral brush dominated environments elsewhere as well. So that canonical model of drier equals more flammable is still reasonable, and it's always true in forests. But in some other settings, it's a bit more complicated, and yet there's still a link to climate change because the desiccation part of that fuel accumulation desiccation cycle is becoming much more pronounced and occurring following almost every wet period, as opposed to only some wet periods historically. And we saw this, again, this is what happened in Southern California. We went from near record wet conditions in spring 2024 to suddenly to near record dry in December 2024, right before the fires broke out. And then we know what happened in January when the winds arrived. And I've added, just for this slide today, a green arrow back in the other direction because as of this fall, we're back to experiencing record wet conditions in portions of Southern California. So despite seeing by far the most destructive wildfires in Southern California history, this same calendar year, we're back to record wet conditions. So that record severe wildfire in Southern California managed to occur sandwiched in between two record wet periods in that part of the state, which is a fairly remarkable statistic, and yet did coincide with, at the moment, record dry conditions for January in between. Really kind of an almost implausibly extreme degree of hydroclimate whiplash. And so all of this, brings me to what I think it was former Governor Jerry Brown who may have coined the term the new abnormal, which I think is more appropriate than new normal because it correctly connotes that uh, things are continuing to change and we shouldn't get too used to the present because tomorrow will look still different, is that there's going to be additional further warming, as I mentioned. And so this is something we're going to have to manage the risks of. We're not going to be able to escape those risks. So it really is a question of management. And we know, that prescribed fire is one of the tools in the toolbox to do so. And so we actually looked at this a couple of years ago about how climate change might change windows of favorability for imposing or engaging in prescribed burning on the landscape. Because it can offer both ecological and then maybe more directly, risk reduction benefits to communities. Um, and I know the fire folks here probably already know this, but for the benefit of everybody else, prescribed burning is generally going to occur under a set of conditions that you can call them sort of Goldilocks conditions from I guess from the nursery rhyme or fairy tale. Uh, where you can't be too hot, dry, and windy for obvious reasons. You might accidentally spark a dangerous wildfire. But you also can't do it if it's too cold and damp because you just don't get either any combustion or adequate combustion to really achieve your goals. You just produce a lot of smoke, which nobody wants, and don't really get much risk reduction or vegetation consumption, which you want in this case. So it's these under the set of not too hot, not too dry, not too windy, but also not too cold, damp, and stagnant. So you kind of got to pick out the conditions in the most moderate zone in the middle there. And we find that on average, climate change is probably going to decrease the number of days that are favorable for prescribed fire across most of California. But I'm not totally sure this is the bad news picture that a lot of folks assume that it always is for two key reasons. One is that even with this huge reduction in some parts of coastal California and the Southwest in the number of days each year that are likely to be favorable for safe and effective prescribed burning, there will still be far more days available than we're currently using. So even if we lost half of the days that are currently meteorologically favorable for prescribed fire, we could still double the number of days that we actually conduct prescribed burns on, even after losing half of those days, because they are so underutilized historically, for example. The other thing to realize is that in places like Northern California, and this does include Marin County, by the way, we might actually see a net increase in the number of winter days that are favorable for prescribed fire. So we might lose days throughout the calendar year, but if places like Marin County can find the personnel and the community buy-in to perform some of these opportunistically some winters, when it's especially during drier winters, that might actually present a new window of opportunity to do so safely. Because by burning in winter, you don't have to deal with the summer or autumn like dryness of vegetation and winds, and you often have the promise that rain is usually not too far, or at least a nice foggy day on the horizon. So I think it's a mixed picture. The future definitely looks different, but I think there's a lot that you can still be leveraged here if we choose to do so. So then that really just comes down to that critical question: Can we, can land and fire management agencies pivot to year-round burning to a much greater degree than we have? This is going to be a challenge at the federal level, but in local communities and in counties, at the county level, this is actually something that might be a tractable thing to address. That's one advantage of being involved in your local communities, is that things can move faster and not get as bogged down by what's going on at the national level. So I think what we've seen unambiguously, and unfortunately, this is another slide I've been able to add another panel to just about every couple of years for the past decade, that catastrophic fire in the urban wildland interface, and even well into the urban footprint, really, as we've seen recently, it is an accelerating crisis, but it's also not inevitable. And I think the key question is really whether we are going to, not whether we can, since there's a lot of evidence that we can, but the question is, will we decouple the increasingly extreme wildfire burning conditions, the increasing number of severe wildfires, from catastrophic outcomes? And I think that's sort of where the rubber really is going to meet the road here, because we're going to see further increases in wildfire risk, but we don't necessarily have to see further increase in wildfire disaster. In fact, I think in an ideal world, you could see an increase in risk even as the actual number and severity of disasters decreases through effective mitigation. I think that's a very achievable goal if we really do what needs to be done to make it happen. All right, so summing it all up, what should we expect in warming California? Well, one of them is an increased intensity of precipitation. So it isn't necessarily going to rain more often or more on average, but literally, when it rains, increasingly it will pour. And the same is true of overall aridity. A reader on the Weather West blog, as well as others, have suggested a similar parallelism, that when it dries, it desiccates. So increasingly, when it rains, it pours, and increasingly, when it dries, it desiccates. Dramatic loss of mountain snowpack. Marin County, this is a bit less of an issue. Mount Tam never had much of a snowpack, except on those very occasional days. But more extreme heat, more intense runoff will be something that Marin experiences. Sea level rise, I didn't talk about it much today, but that is also a concern in coastal communities, including in Marin. And as we saw with the pretty significant flooding just from a king tide event just this past week, in places that, have historically gotten some ponding, but this week we're genuinely inundated. Those sea levels are just creeping ever higher. So the theme really is increased variability, increased whiplash, wider swings. The driest dries, still drier. The very wettest periods are going to likely get wetter. And I suppose that's a blessing and a curse, right? Depending on context and preparedness. Because if it was really just going to get drier all the time, as I think a lot of folks maybe assumed in the 2010s drought era, that would be really bad news for a lot of California. It would mean that we really don't have adequate infrastructure, adequate water to maintain California's lifestyle and population as they are. But the reality appears to be that we're still going to get that water, but it's going to come in increasingly inconvenient and intense bursts, which is still a problem. It's a different problem, though, than not having any water to work with at all. So the real challenge will be preparing for worse droughts, worse floods, worse wildfires, but probably less running out of water completely. So the nature of the problem is different, and if you want to make the future better, you got to correctly identify what the problem is in the first place. So flexible and proactive interventions then that are commensurate with variability and whiplash are what's going to be needed. And that's it's commensurate with that increasing whiplash. And so I think I've covered sort of how do we adapt to that. So I'll skip to the end here. As was mentioned in the introduction, I'm very accessible online. You can find me on various social media platforms, many of which are listed here. And so I'll leave this up for a second. I'm going to take a sip of water, but I did want to add just one bonus slide at the end here on where we are with emissions and decarbonization. And then I think we can open it up to questions. So just give me another moment here. All right. So these are the two slides that I just popped in here, uh, literally as the introductions were going on. These were created by my colleague Zach Labe, who's now with Climate Central. He was among the folks who was fired by the federal government for no particular reason earlier this year, but fortunately has been able to continue along with several other folks who were picked up by Climate Central to do similar work to what their federal roles had entailed. And Zach does a lot of good science, but also produces some great visualization and analyses. You can find these too on his website along with dozens of others. It's actually a dizzying array of climate quantification. But really, there's a few things I wanted to illustrate here. You've already seen the increasing temperatures over time chart and the fact that 2024 was by far the warmest year on record. That's not too surprising. What I really wanted to draw people's attention to, these are the other three panels here, are greenhouse gas levels in the atmosphere, the actual concentration of the planet warming pollution that we're all so concerned about. And upper right is carbon dioxide concentration, lower left is methane, lower right is nitrous oxide. And that is roughly the order of importance. Carbon dioxide is the number one, but methane is still pretty important, even though it's number two, and nitrous oxide, although it's a more distant third, is still contributing a meaningful amount of warming. But the main point is, you can kind of squint a little bit and ignore the exact numbers, but look at the shape of the curve. And you tell me if you see that curve reversing, either for carbon dioxide or for methane, or for that matter, nitrous oxide. What I see is that the levels of all of these planet warming gases continue to increase at a rate that is at least as high as we've observed previously, and in some cases at a higher rate than was the case historically. And I think this really tells the tale. So you can kind of ignore the left plot here, but focus on the right plot, radiative forcing. That's a scientific term. What does it mean? Well, the units are watts per meter squared. So essentially it's energy per area. So it's what it's saying is not just that the energy per area is increasing over time, which would already be concerning, but that the amount by which that energy per area is increasing over time is itself increasing over time. That's known as an acceleration, in other terms. And ultimately, when we talk about all of these fancy numbers, greenhouse gas concentrations, parts per million of CO2, methane, nitrous oxide, all of these technical chemical stuff, what the atmosphere actually sees in the end is this number here. It's the radiative forcing. It means what is the overall warming effect of all the stuff that we're doing to the atmosphere? And any number above zero on this plot on the right means that there is ongoing warming happening. So if this line for radiative forcing was flat and horizontal, that itself would mean that the temperature over time was increasing. So a flat horizontal line on the right would mean steady global warming. But an increasing slope in this radiative forcing means global warming that is warming faster with each passing year. And that's sort of where we are right now. So we've seen progress with green energy. We've seen progress in the electrical sector. We've seen progress with transportation, all of these things. But ultimately, this is the number that needs to flatline and actually decrease all the way to zero sooner rather than later. And we just haven't seen that happen yet. And so I think that this is, we're a little bit we're kind of at a crossroads here because this is roughly the point where all of those simulations, all of those projections regarding the future assumed that society was going to get its act together and very, very dramatically, very abruptly and suddenly bend this curve. That has not happened yet. It certainly still could happen, but it hasn't happened yet. And so that is why what my main message is one of sort of balance between mitigation and adaptation. We can't solve the problem without, well, solving the underlying problem of greenhouse gases contributing to climate change. There's no question there. But if we only focus on that, and I think this is something that California, despite being a leader in decarbonization, has actually been behind on historically, adaptation is uh, also going to be of equal importance because we can't solve this problem overnight. And I think we have to be serious about ways in which we can reduce the risk of bad things happening in the meantime, from local to international scales. So this is sort of where we are now. And I wish I had a different curve to show. I wish I could show you that in the last couple of years, this line was at least flattening out or that it was even better, decreasing. But this is what I've got for you in this moment. So I don't want to end on too dark a note. So I think it would be nice to have some questions, and we can talk about anything from California climate to fog, to wildfire to prescribed burning to carbon emissions. I'll try my best to address what we've got. And so I see that it's currently 22 past the hour. I think that means we have a fair bit of time for some discussion. So I'm going to stop sharing my screen. You'll see me come back up. And depending on how many questions, comments we've got, we can go from there.
Great. Well, thank you so much, Daniel. Let me ask a couple of questions out of the chat, and if people have additional questions they want to add to the chat, this is the time to do it. Earlier, when you were talking about the increased risk of significant flooding in the Sacramento and San Joaquin Valley, you used the term mega flood. Can you define that in some way?
Yeah, so there are actually very formal definitions of it if you're like a paleogeologist or if you're a fluvial geomorphologist. We're using it in a slightly more colloquial context here. But essentially what we're referring to is a large scale, so not just one, watershed or two watersheds, but a many watershed over a multi-hundred mile type region of flooding that is significantly worse than the worst observed historical floods. So we're talking about floods that probably have a recurrence interval on a large scale context of hundreds of years, at least in a stable climate. Now, our point is that they won't be so mega moving forward in that something that would have occurred maybe once every few centuries, 100 or 200 years ago, something that most of us probably would never actually live to experience, um, will likely be something that's closer to a 20 to 50 year flood, which means that it's actually something that most of us probably will experience. That's a pretty profound difference in the magnitude. So that's kind of what where we're going with that kind of language. But with the mega prefix there, it isn't an extremely quantitative definition, but it's sort of a qualitative definition of a much larger than historically observed flood event of some variety.
We have a couple of questions that are sort of, I think, keying off of the your discussion about prescribed burns and the fact there's maybe, well, more times when we can be doing those. And I know that's a topic of particular interest to many in this group. Um, One, Jim Casper asks, do we need air quality districts, fire agencies? Do they need to be more nimble to take advantage of possible burn days in the winter that is, to be more at the ready when there's a break between winter storms? I definitely would add the air quality make sure the air quality districts are emphasized in that because we have to meet their regs to be able to do prescribed burns.
Yeah, and that's actually an impediment that's been identified by all of our prescribed burning practitioners who are on that co-authors list on that paper. So the regulatory constraints and also community concerns regarding smoke are perceived, at least, as being the number one impediment to prescribed burning in a lot of regions. And that's understandable because I don't think anybody likes to breathe in smoke. And, ultimately, any smoke is not great to be breathing in. The optimal amount of wood smoke to breathe in is zero. But we don't live in an ideal world, right? And so I think the question is, what is the way to minimize the amount of smoke-related air pollution in the long run, while also not exposing people in the short run to unacceptable amounts of air pollution for whatever reason, whether that's a prescribed burn or a wildfire, or, people still burn an awful lot of wood and wood burning stoves in the Bay Area, and that really degrades wintertime air quality. So there's a lot of sources for that particulate smoke pollution. There's good reasons why it is regulated. It's personally actually a pet peeve when the neighbor on a temperature inversion day puts some logs on the fire, and then it means that we have to immediately close all of our windows for the next 2 days,
Mhm.
turn on the air filters. But I, I think that yes, I think nimbleness is a good way to put it in terms of air quality regulation. It's also a good way to put it in terms of flood risk management, fire risk. Nimbleness is important in all these things, and we don't have it. We don't necessarily have regulatory agencies that are as responsive as they need to be because there will be windows of opportunity. There will be really good windows to do this kind of stuff. And there'll be other windows that are either not good to do it for flammability, safety reasons, or because it can be too wet and then you don't get anything done, or it can be like right now, for example, probably would not be a great time, even though you could probably get some combustion going under the fog layer. The problem is all that smoke is going to be trapped near the ground level. It would be trapped near the ground level. People would be breathing it in for days on end. So this kind of pattern that you're having, like this week, for example, your mileage may vary depending on where you are, but in general, under the inversion, you don't want to smoke people out for days on end. And so, but yes, I think that having air quality regulations, both the regulations themselves and then the agencies that are making day-to-day decisions and on these sorts of things probably need to be weighing a wider range of risks and benefits and maybe being more responsive to conditions as they evolve. Because I think we're both missing some days that would be great days for doing this kind of thing, and also there are probably some, temperature inversion, stagnant wind days when it would be better not to introduce more pollutants into the air, where maybe we need to be clearer about why, regardless of the source, whether it's fireplaces or ag burning or prescribed burning. So I think there's a lot of room for improvement there, but the good news is all of that's, almost all of that's local to regional scale regulation. So again, it's something that there's actually some hope that you can change things at that scale relatively quickly.
Yeah.
Um, Harold Hedelman asked, and the prescribed burning, Mark, we may want to get you in here in a minute to answer some questions on prescribed burning. But Harold Hedelman asks, can you discuss why without carbon dioxide removal, emission reduction just can't get us to net zero? And even if achieved, net zero will leave us worse off than today? Not sure I understand the second part about that, but take a shot at it.
So I think there's a lot of rhetoric surrounding this notion of net zero, and all that it really means is that curve that I showed you, that carbon curve, essentially has to get to zero in order for global warming to stop. Net zero means that there might be a little bit of wiggle room. We might not have to go all the way to zero in terms of our emissions if we're also essentially, I mean, not literally, but maybe more literal than maybe you might realize, vacuuming some of that carbon right back out of the atmosphere and sequestering it somehow technologically. Essentially saying, is there any wiggle? I mean, so essentially, the argument against net zero is that it's an excuse to continue to combust fossil fuel at large scales, even though we know that's very bad for us. And I'm not sure that I necessarily agree with that framing because ultimately what the atmosphere cares about is net zero. It's if you can get to net zero from an atmospheric perspective, if you're balancing your emissions with your carbon sequestration in some way, then you actually have solved the problem of global warming. Now the problem is there's been a lot of essentially sales pitches regarding carbon sequestration. And I think a lot of agencies and entities and governments have essentially been sold a bill of goods. There's not a lot of evidence we can do carbon sequestration at scale that will actually meaningfully help with getting to net zero. So increasingly, I think the reality is that net zero is fine in principle, except that in practice, net zero is probably very close to actually just getting to zero in terms of emissions because we do not appear to have the ability to successfully sequester large amounts of carbon either through technological means. There's direct air capture plants, many of which have closed in the past year because they were not
Mhm.
economical and they're not working well. There have been a lot of attempts to use things like carbon credits to sequester carbon in forests, for example, but the recent research is suggesting that nearly all of those carbon credits from forests were phantom or ghost credits, and a lot of that is because of wildfire. A lot of those forests that were used for credit-based carbon sequestration and cap and trade included in some places literally went up in smoke, and almost all of that carbon has already been released back to the atmosphere and then some. So that's my concern with net zero is not so much that if we could achieve it, it would be bad. It would actually, I think, be a tremendous success. I'm just not sure that it really exists distinct from actually getting to zero carbon emissions anyway, because of the very poor track record in actually being able to implement the kinds of things like direct air capture and biosphere related. Maybe we will find something. The reason I wouldn't want to rule it out is that if we do, in fact, in 10 or 20 years, figure something out that works really well, it could be a really beneficial, helpful thing that could actually be a good news surprise. But we don't have that right now. So that's my concern with it.
And that actually is an excellent segue into another topic that you alluded to earlier. But you're right. The notion that we're going to achieve net zero by direct air capture or by carbon sequestration is certainly viewed by a lot of folks as just an excuse to keep burning fossil fuels as long as we can while we have some mythical technological fix. Carolyn Shoulders had asked, it seems that public communications, right, climate change are getting pushed below the radar. What sort of public communications do you think would help boost public demand for solving the problem? I mean, how are we gonna get the public turned around short of a year with four major hurricanes hitting Florida?
I mean, that wouldn't do it. I'm 100% certain that that wouldn't do it. We can't assume that the increasingly extreme events are gonna change the status quo. They haven't because we've
Mhm.
seen that.
Yeah.
If you had been talking to people in circa 2005 in California, and you had told them that five, six significant communities would be completely and totally wiped off the map with multi-thousand or even like tens of thousand level structural loss and wildfires, I don't think anybody really would have believed you based on history. And, we're starting to grapple with that problem specifically of wildfire more than we used to, but I don't really think there's been a sea change in the perception of climate change or in our progress toward addressing it, even at the state level in that period. So I think I don't think we can rely on, extreme disasters as catalysts for behavior, change. It really is a very different. I mean, if I had the solution, I wish I did. I think one of the challenges is we really disincentivize talking about this sort of thing. I'm really lucky to have a professional role where part of my job is to talk to people about these things and engage with communities and engage, maybe even more importantly, with large scale media. I've had 5 news interviews today.
Mm.
And for example, there is essentially nobody else who does that in the climate world. And it's not necessarily because they don't want to, it's not because they wouldn't be good at it, it's not because they don't think it's important, but there is absolutely bottom of the barrel institutional support. Universities do not support this. Government agencies, state agencies make it extremely difficult for their employees to speak on the record with journalists, for example, or to speak contemporaneously in public. Certainly at the federal level, that's a whole different can of worms these days. But this is even true, with local and state government in a lot of cases. So who is actually going to be spearheading these conversations? If none of the institutional settings in which we have domain experts in the space who can talk about these things are going to support people in having those conversations, well, it's not that surprising that we don't have them more often. And so I think it's a little more complicated than we just need to talk about it more because, clearly that isn't enough. But also, I certainly think it would help if it was more prevalent in, day-to-day interactions. The average American, by the way, says that they have not heard even the words climate change spoken in their daily life. Something like 75 or 80% of Americans say they never hear about climate change at all. And this is because two-thirds of Americans don't consume any actual news anymore. So where do you hear about it? Unless somebody in your community is organically talking about it when you get your morning coffee or when you go to the grocery store or when you meet up with people wherever. If not there, the majority of humans on Earth aren't going to be hearing about these sorts of issues or the challenges or the solutions to them. So to that extent, talking about it is a powerful thing that can be done. But that's a very grassroots kind of solution to that is to actually talk about it and to encourage. I hesitate to use the word coerce, but coerce institutions into supporting that kind of those kinds of efforts because right now it's just vanishingly hard to get that institutional support for people to have those sustained conversations.
I just like to say something here that if you could take the lessons of the speech, the talk that you gave to us, and you could say, okay, I really want to talk to a public group about this. Someone's raising a lot of questions about wildfires. Don't have to worry anymore because we're getting so much rain or whatever it is, whatever thing that doesn't is not true. Um, do you have a scenario for that of how you would translate what you talked about today into a sort of topic talking points for a public?
Well, I think that's part of why I think the whiplash paradigm is so important, is I think it helps to, and the expanding atmospheric sponge analogy, because it really helps explain by why one change that we understand really well amid a lot of other uncertainties, but this is one thing we really do understand quite well underpins both sides of that coin. And it might be true that, right now, for example, there's a pretty close to zero risk of a significant wildfire, right, in Marin or in LA, where they had just an incredible deluge for much of the fall. So it's true that right now, fortunately, it doesn't really need to be on your radar right now. It doesn't mean we won't be in a different place next summer, next fall, or the year after, but it's fair to say that right now, unlike last year, where a lot of us were very concerned, in early December, what the conditions we were seeing in Southern California going into its strong wind season, and we all know how that turned out, there is not the same concern right now. And so I think part of it is learning like when it is okay to take a breather, because, right now, California is not at risk of flood or fire. I mean, I know people don't like the fog, but in a lot of ways, as long as you keep your following distances on the highway, it's a very benign weather pattern, right? And so you can kind of take that sigh of relief. Hopefully, there's not too much wood burning going on in your neighborhood, but I think so. We live in an era of poly-crisis, unfortunately, but it also means you kind of need to learn to sort of like when it is okay to take a step back and think about the bigger picture and sort of, plan for the next thing because you do need to take those opportunities. And that's sort of where I emphasize that in by virtue of having the swings, the saving grace is you do have to pass through, if briefly, through some relatively comfortable place in between, right? You do have to pass through somewhere close to average if you're swinging from drought to flood or vice versa. Sometimes it's more sudden than we'd like. That's not, I guess, always true, but often we'll have those in between periods. And those are the times when it's just so important to regroup and to plan and to this is why it's so important to have plans about what you're going to do once the conditions are benign, when they are favorable, because you might not have a long window. So you need to know how you're going to use it to good effect before it opens up. Because if you wait until it opens up to start planning, then you're just going to waste the window with your discussions rather than actually, putting feet on the ground, putting words to action. So that I think that would be my response to that one.
Yeah. Bill?
Let me ask one more question and then we'll go to Bill. Stuart had asked a question that I kind of want to key off of, and this may fit into what you spend a lot of time doing. Is we've been waiting for the insurance companies to, I guess, step in more aggressively based upon, what they're seeing in their losses to try and drive adaptation or mitigation. And I'm wondering what you're hearing in terms of climate modeling by the insurance companies and the reinsurance companies, and them actively driving adaptation or mitigation.
Yes, they are. And I actively work with a number of insurance companies now. So this has been something that's changed a lot in the last 4 or 5 years. So this is something I'm directly involved with increasingly. And they have, I mean, let me put it this way. Insurance companies have become a lot more sophisticated suddenly out of pure necessity in terms of their ability to assess risk. It's still maybe behind the science in some places, but it's much closer to the sort of the state of the science than it was 5 or 10 years ago. So we're in this moment where the insurance industry is scrambling to catch up, and since they've incurred a lot of losses in terms of wildfires in California and then hurricanes actually in Florida, so your other example is germane there, where they were kind of caught by surprise, where the level of loss has greatly exceeded their worst case scenarios. And, insurance companies are literally in the business of generating plausible worst case scenarios that don't ordinarily get exceeded. There is a type of insurance that is insurance for insurance companies, which is known as reinsurance, which exists to cover those eventualities, and they too have underestimated the magnitude of the wildfire losses that have occurred as well. So there's been a real reckoning. There's a lot of interest, I will say, and this is good, in getting the risk assessments right, because I don't think it's good for anybody, uh, homeowners, people who live somewhere, or the insurance companies if the risks are either over or underestimated considerably, because on the one hand, it's a risk to the companies, on the other hand, it's a risk to everybody else. So you really do want to have the risk be correctly estimated by all parties and agreed upon. I think what's going to start to happen, it's starting to happen now just barely, but I think it's going to be a much bigger part of this moving forward is the insurers will drive partly through pricing and underwriting decisions things like building codes and community level wildfire resilience, investments in firefighting, but maybe more importantly, investments in structure hardening, in building codes, not just for new structures, which is sort of the no-brainer part of it, but also for existing structures, because this was something that frustrated me so much about those who were following the Bill Gates memo and the follow-up to it, which is that one comment offhandedly was that, well, once everything in California burns down, we'll just rebuild it in a fire resilient way. And saying, okay, so that presumes that all communities in fire-prone areas burn to the ground, which of course is not a desirable outcome. I think it's fair to say. So the reality is we don't want that to happen, but for it not to happen, we have to then think about how we retrofit existing structures and how we do vegetation treatments and prescribed burning and evacuation drills and emergency communication improvements in places before the fires occur. And I think insurance companies are starting to get more involved in advocating for that, incentivizing it, either directly or indirectly. Where are the lobbyists when you need them? From whenever it's anyway, I think the challenge is in articulating to people who, since insurance is usually an individual property level decision, right? A person or an entity buys residential or commercial insurance for their property or for the properties they own. It should be the case, in my view, that people, and especially neighborhoods that get really serious about structure hardening and zone zero and these larger scale vegetation management plans and do a good job with it, really should get a pretty large break on that component of the insurance premium, right? Because presumably the risk has actually significantly decreased that the insurer will actually have to pay out on those properties relative to similar properties in the same area that have not done so. There's all sorts of regulatory, ethical, legal reasons why that's complicated, which I won't get into. But I think the net effect is that is starting to happen. As of today, in California, most insurers have some specific discounts for specific actions that you, the individual homeowner, can take. They're not huge, they're kind of token adjustments to your premium right now. But I think as the benefits of that become clearer and as the regulatory and legal framework becomes more amenable, I think um, then we will see that the pricing structure is going to drive a lot of this change structurally. The hope is that it doesn't drive people out of their homes in the meantime, where everyone's premiums are just going through the roof, possibly because of a bit of an overcorrection. Insurance companies are pricing in the last decade as if it's going to continue to get worse at the same rate for the next decade in a lot of cases. And that's probably not true. It probably won't. We're certainly in a new regime, a fire risk, but I also don't think it's true that we're just going to see another decade that is that much worse than the previous decade than the 2010s were relative to the decade before. So I think that there's this tension right now where it's in everyone's best interest if the insurance companies can estimate the risks accurately and figure out what interventions are the most effective in reducing their exposure and then passing that on to the people who are actually buying these insurance policies by incentivizing people to do things that reduce the risk, which makes sense for everybody.
Yeah.
Mark Brown, do you have anything to add to this discussion?
And insurance it takes up about 25% of my time now, I think. And um, in the same way that we are not going to solve the climate crisis, we are not going to solve the wildfire crisis in silos, that we need to do it collectively as a whole. The insurance crisis is going to be something that has to be solved as a whole. But also, I think the insurance crisis, solving the insurance crisis, can help solve the wildfire crisis, and that they can go hand in hand. Um, and considering what Daniel was talking about and catastrophic risk modeling, Prop 103 says that we can't use catastrophic risk, or insurers cannot use catastrophic risk modeling to set rates. And so that they were using a rearward facing lens of 20 years of catastrophic losses to predict what was going to happen in the future. So roll back time 10 years ago. There hadn't been 20 years of huge catastrophic losses, and they're setting those rates, those losses. Now we're 10 years forward. 10 years of low losses have fallen off the balance table, and now we have 10 years of really high catastrophic losses. And the worry was that catastrophic risk modeling would increase our rates because they're going to build in climate change. Well, our rates are going up anyway because all the low catastrophic years have fallen off the balance table. And also, the rearward lens does not take into account any of the work that agencies like Marin Wildfire are doing. Doesn't take any into account that what our homeowners are doing, where they're home hardening and defensible space work.
Right.
So that's why Commissioner Lara has created the sustainable insurance strategy that is incentivizing insurers to insure in high risk communities. If they do that, they're going to have access to cat risk modeling for rate increases, which I think in the long run will end up being a good thing for us, because now we are sharing our data for our community risk level work. And then as our residents start working with their insurers and showing that they've done their home hardening and defensible space, that's going to increase insurance availability. If we increase insurance availability, then rates will start going down with the increase of availability. But a lot of our communities want to look at the insurers to be the people that hold our residents accountable. The insurers are starting to push back on that and say, no, 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 we need you as communities to holding your communities accountable for what needs to get done through, like Daniel was talking about, ordinances, codes, and laws. So it's going to be a balance.
Yeah, and that's a good point. I mean, that's essentially what I mean. What Mark was just saying about the ability to use. I mean, the industry term is cat risk modeling, but catastrophic risk modeling, which is essentially saying that you don't strictly rely on just looking at what's happened in the recent history as a guide to what's going to happen next. And that, to somebody who studies extreme events, never made sense at all from a scientific or actuarial sense. It always means you're perpetually going to over or undershoot. It's very unlikely that you end up in the right place in terms of estimating risk. So exactly as Mark just described, I think what's likely to happen, contrary to initial expectation that it would radically increase rates relative to the potential overcorrection in rates, I think that we've just seen, it might actually help level things out in the medium term because you'll more correctly say, yes, the risk is higher than it used to be, but we're not going to get 2020 every year. And I think that that's probably a more realistic view. And you can't do that with the existing framework for how insurers are required to set rates. You can't say we don't think moving forward, we think that the future is going to look different from the past because of that essentially that regulation. So then the whole another problem becomes how do you build credible cat risk models in this setting? And that is the billion-plus-dollar question where all these insurers are partnering up with a lot of different companies to try and actually implement that.
So I would like to ask some people who have their hands up for a while, a slightly different question. Bill Carney, you had a question, and then there's uh, Bob Archer, and David. Did you have a question, David Muller? I don't know, but okay. But Bill, I saw you did. Are you still there?
Yeah, actually, it's in the chat. My question was, well, my concern is that the resources we have always are limited, and that we need to resolve any competition between preparing for climate impacts and actually solving the causes of climate change. So my question to you, Daniel, is, are there ways to prepare for climate impacts that also significantly reduce greenhouse gases?
It's a good question. I mean, I think that there can be in some settings. So things like prescribed fire, for example, is actually a pretty good example of something that could potentially do both. Because if you look at the long run, carbon stores, especially in forests,
Uh-huh.
where the lack of fire, in some cases, in recent decades of the past century or two, in western forests, for example, has resulted in a forest that is not necessarily its healthiest, that is more flammable, precisely at a moment when we're increasing the flammability of forests. The real risk is that you have a high intensity, large scale fire that runs through some of these very carbon intensive ecosystems and releases almost all of that carbon all at once in one big pulse because it's not coming back quickly. You cannot regrow a mature, healthy forest in a year or a decade. If, it takes much longer than that. And so that carbon, it's not gone. I mean, the forest, the vegetation will eventually regrow and sequester carbon, but the volume of carbon that's sequestered in a mature forest is huge. And if you have a high intensity fire that runs through it, for example, today or next year, you don't have that forest, all that carbon that was in the forest and not in the atmosphere is now in the atmosphere for the foreseeable decades. If instead you have engaged in prescribed fire treatments or other sorts of ecologically minded treatments in advance of that potentially catastrophic forest fire, for example, which would have residual benefits to surrounding communities because the risk of a catastrophic fire is generally going to be lower in cases where you've done appropriate prescribed fire treatments, adjacent to communities. You might still get that fire in that forest, but fire in a forest is not inherently a bad thing. And if you've done that prescribed burning and ecologically minded treatments before the fire moves through, it is far more likely that the mature trees in that forest are going to be just fine on the back end of that fire. They'll continue to grow. Their canopy and their root systems will continue to sequester that carbon for decades, I don't know, maybe centuries more. And that's a risk reducing intervention, for example, prescribed fire that has direct benefits for communities in terms of making it less likely that your house is going to burn down, but also does actually have net carbon sequestration benefits in most cases in the long run. People worry about intentionally burning things and saying, well, isn't that emitting carbon up front? And it is. But in most cases, it's emitting like an order of magnitude or maybe two orders of magnitude. So we're talking about 10 to 100 times less carbon in some cases in a prescribed burn in a given environment than an uncontrolled crown fire in that same setting, because essentially you're consuming a much larger fraction of the biomass in the fire, but you're also, in the wake of the fire, in the case of an uncontrolled fire, leaving an ecosystem that is greatly degraded in its ability to store carbon, whereas in the wake of a lower intensity fire in a lot of these ecosystems, that's actually a beneficial thing for some of the species there, and they will actually be adding a lot of carbon in the process of recovering from that lower intensity fire right away. So this is a bit of a generalization. You can't extrapolate this everywhere. The same thing that's true in a coniferous forest. It's not the same. It's not necessarily true in a chaparral setting in coastal Southern California, but in general, that's one example. There's a similar example with floodplain restoration, for example. If we give our rivers some room to roam, our rivers and streams where we can, that helps reduce the risk of unwanted flooding because you let places flood that should have flooded, that naturally would have flooded, that have ecological benefits from flooding, reducing the likelihood that the places you really don't want to flood, like your house or the local hospital or whatever, from flooding, because you've given that water more space to move around. But that also actually, there may also be some carbon benefits there as well in terms of those restored riverine ecosystems, those watersheds, those wetlands, all of these things. So there's some natural climate interventions, natural climate solutions that are actually extreme weather risk mitigation tools as well. So that's the good news there. I will also say that to a large degree, a lot of the interventions are somewhat orthogonal to each other. So there are a lot of adaptation, risk reducing interventions that are just different. They don't necessarily make climate change worse, but they're just solving a different problem than solving the carbon emission problem. And so there is some overlap. And I think, as you point out, those are probably things that are kind of no-brainer interventions, right? We should be doing them because they really do buy us both things in some proportion. But there's also going to be a lot of things that we need to do that really do focus more squarely on one or the other. And so, we'll need to do a mix of both of these things. But there are some nice opportunities to sort of do both at once.
Yeah. Okay, Bob?
Yes, thank you. Excellent presentation, including the reality charts at the end. An observation that those global emission charts of the three gases and the radiative forcing are based on global emissions. And I think it's important to keep in context that 61+% and growing at the fastest rate are the emissions from 21 emerging economies. 28% of emissions are from the major economies, the G7 countries, 11% from the US, and 1% from California. Does this lead us to a national approach that looks at policies that incentivize emerging economies? And secondly, that greatly accelerate technology development and dissemination outside the electricity sector where there is progress?
Well, that would certainly be a critical part of any successful portfolio to address this. It's still true, by the way, that the majority of cumulative historical emissions have still come from essentially the United States plus Europe. But that instantaneously, as of today, 2025 emissions will primarily be from India, China, and other developing nations. So that those curves have crossed over each other in recent years. Um, so it's true. And the challenge is that that was part of the planned, economic geopolitical policy that was sort of envisioned circa the Paris Agreement. And it hasn't really happened at the scale. There has not been that much support in the scheme of things for developing nations to develop in a green way. Uh, some countries are doing it anyway, which is the good news, I guess, in all of this. Some countries are doing it anyway, but some are not. And that's going to be a big problem to the extent that some very large countries, home to hundreds of millions or even billions of people, are doing a better job than others. China's emissions have skyrocketed, but they may already be peaking. They had a much shorter acceleration period than did the US over the better part of a century. And because so many people live there, even if they peak now and then begin to decline, that's going to result in a big carbon pulse still moving forward into the future. And India, for example, is behind China. That's a billion plus people whose economy is going to generate a lot of carbon moving forward too. So I think, yes, that should be a big part of this. We just saw a failure of the COP30 climate conference to do just that, to reallocate more of the sort of the global north resources to the global south to develop in that kind of way. So I'm hopeful that that happens anyway, but it's going to be harder. It's going to be slower unless there is that level of investment. And that is partly why we don't see more progress on some of these carbon emission trajectories, relative to what we might have hoped from 5 or 10 years ago. That was one of the things we were kind of hoping would really take off, and it hasn't yet. So it's th that is one of the big concerns at the moment. It would be great if we did that. And yes, that is going to be an increasingly big part of the picture moving forward. So the question is, will we do it?
Yeah. Well, it looks like, I hate to say it, but it is 4 o'clock.
So we're at time.
And we're sort of at a time, if there's anything lurking in the chat, or does anyone have a topic they want or a subject that they want to bring up before we call this to an end, because one question leads to another. And one of the things that we keep thinking about is, why is it that flattening of the curve that you were saying had to happen in the future isn't going to happen or hasn't happened? And I, in a way, are you thinking about it? Are you studying it? Are you looking at it? Is this something? It's very troubling.
Well, I think I mean, it really just reemphasizes that that part of it is not so much a physical science question. I'm an atmospheric scientist, and why governments and societies have decided not to do these things is less a question of physics and thermodynamics and more a question of everything else. I mean, I think if you just think about the trajectory globally, geopolitically, world events since the Paris Agreement era, so think, onward from 2018, think of everything that's happened since 2018 globally. We had this hugely disruptive global pandemic we're still experiencing the long tail of, almost 5 years in that completely upended global commerce, global travel, significantly affected global geopolitics. Historians and scholars of collective thought, think that this really shifted uh, political winds globally towards more authoritarianism in a number of countries. It has altered, national political parties and outcomes of elections. And we've seen this huge geopolitical shift in Europe and the US and Australia and a lot of large, wealthy nations in recent years. The balance of geopolitical power has shifted. There's a major war ongoing in Europe. There are multiple wars in the Middle East. And all of these play into who has power, why carbon emissions have gone the way they have, and none of this was necessarily predictable from climate models looking forward from 2018, right? So I think the same will be true of the next decade. Hopefully, the next decade won't be full of pandemic and war, but you don't. My point is, we don't know, uh, you know, this what will happen next. And I think what we saw was a good example of what happens when non-directly climate-related events kind of conspire to put us on a worse climate path than we might have been on had we not had a pandemic, had we not had ge those geopolitical shifts, um, had we not had the wars and the electoral outcomes that we have. So, what does the next decade hold? And I'm not a fortune. The challenge is we can try and predict future climate. I'm not sure that anybody has a good geopolitical model for the future. I mean, there's lots of pundits, but what actually happens next, I think, is difficult to predict, and that's why I think it's hard to give an answer to that.
Yeah.
Yeah. Well,
Uh,
thanks everyone, and particularly you, Daniel. What a wonderful presentation, and geez, we
yeah.
really enjoyed it. And
And I guess we can access your various websites. We want to get more. And
Yes, as always, definitely. I encourage you to do so. And in particular, something that's been really, I think, has been of great interest recently are I host what I call virtual weather and climate office hours, semi-weekly
yeah,
on YouTube, and those have been a really great kind of like this. They're conversations. They're interactive. And they usually have a topical focus week to week, but I'd encourage folks to check out that YouTube channel, the Weather West YouTube channel, and to sign up for those live stream notifications if you want to learn more.
Wonderful. Thanks
I-
again so much. And this has been recorded, and MCL will put it up on our YouTube channel, although it's going to be a couple weeks before we can get that done. So
And so I don't want to say anything about anything else because there's so much to think about here. I want to just leave it fresh in our minds. But I will mention one thing is that we have another session actually on the 13th of January on prescribed burns. And we're really looking forward to it. It's countywide, and we have people who have been expert in implementing it and studying it and telling us how to deal with it. So do come, and we'll be in touch. And Daniel, so very many thanks. I don't even thank you isn't a good word, but that's what we're saying. Appreciate it very, very much.
Yeah.
Yeah. Is anybody?
Thank you again.
Thank you.